Okay guys, so we spent a lot of last lesson looking at building parts of an equation and solving parts of an equation, but we didn't really look at actual equations. So if we look back to our definition, it says an equation is two number sentences separated by an equals sign. And in our last lesson we were only really looking at the very basics, we were only really looking at one side. But there were lots of really helpful skills that you guys will need to know when solving equations. So today we're going to look at actual full-blown equations with pronumerals, with the equal signs, and with both sides of them. So the heading for your theory book is solving equations, and you'll need to write down the following words that are on the slide here. So solving equations is like balancing scales. What we do to one side, we have to do to the other. Like you learnt last lesson, when we solve equations, we use this thing called inverse operations. Now, inverse is just a fancy word that means opposite. Now, equations can have one step. You did a few of those in the last lesson. Or they can be a bit more tricky and they can have two steps. So we're going to have a look at a few examples, and hopefully the prep that we did in last lesson will help you guys out a bit. So our first example of a one-step basic equation, x plus 7 equals 15. Really simple, guys. We've got our pronumeral here, x. This is our unknown. This is our murder suspect. Now we have to remove all the evidence around him in order to work out who he is. So, inverse operations, we do the reverse. So, if x plus 7 is 15, we then just do the opposite. X equals 15 minus 7. Therefore, x equals 8. It's as simple as that, guys. X plus 7 equals 15. We do the inverse. X equals 15 minus 7. Therefore, x equals 8. Really straightforward. Another example. We'll go 15 plus x equals 18. Again, our 15 here, we're looking here at the 15. It is a positive number. We know this because it doesn't have a negative number in front of it. So the 15 is a positive number. So we should have we can pop in a plus here. Do that if it helps you remember. So, opposite, inverse. We do the opposite thing to the other side. So x equals 18 minus 15. X equals 3. Really straightforward. Let's try a little bit more of a tricky one. I'm going to draw another line across here. Let's try this one. 12 equals 3y. Now remember what we were looking at last lesson. We were saying if you have a statement like this, 3y, that means 3 multiplied by y. We don't use the multiplication symbol though. We just say 3y. So, if 3y equals 12, we can write that the other way around. We can write 3y equals 12, if that makes a little bit more sense to you. Then, we do the inverse. So, 3 multiplied by y, the inverse of multiplication is division, so it would be y equals 12 divided by 3. 12 divided by 3, 4. Simple as that. So if you have the pronumeral on the right hand side, guys, if you understand it, that's fine, but it tends to be a better idea to put the pronumeral on the left hand side, like we've done in the second one here. So it's a good habit, if you have the pronumeral on the right, immediately flip the sides around. Doesn't make a change if you flip the sides around, because both sides are equal. Remember the scale example? We're trying to balance the scales. Both sides are equal. Okay, let's try another tricky one. We've got one that's a little bit more tricky. M on 4 equals 4. So, again, when we see this, guys, when we see something that looks like that, what that's saying is that's saying m divided by 4. What's the inverse of division? Multiplication. So m equals 4 multiplied by 4. 4 times 4, 16. Pretty straightforward. Okay guys, now we're going to look at an example of one-step equations that involve negative integers or negative numbers. So, let's have a look at our first example, y. Again, I'm just trying to change it up. You guys got angry that I used x so much, so we're going with y. Y minus 4 equals negative 4. So, y subtracted by 4 equals negative 4. So we do exactly the same thing as we did last time. Negative 4, what's the inverse of subtracting 4? It's adding 4. So y equals minus 4 plus 4. What's minus 4 plus 4? Y equals 0. Seems a bit funny, doesn't it? Does that seem right? Well, it is. A good way to check is to substitute the answer into the equation. So we can go 0 minus 4 equals minus 4. Does it? 0 minus 4? Yes, it does. Therefore, we must have got the answer right. So if you ever want to check if your equation or the answer that you've got for the equation for the pronumeral is right, just substitute the answer into the question. So let's try another one. What have we got here? P minus 9. Oh, let me get my 9 in here. 9 equals minus 4. Really straightforward. So, again, our 9 here, it's the negative, we're subtracting, so we go P equals minus 4 plus 9, P equals 5. Should be pretty straightforward for all of you guys. It's not hard, it's not challenging, but all it takes is a little bit of practice to get used to it. So let's try a little bit more of a challenging one with an integer, with a negative integer, sorry. So we've got x on 3, or x divided by 3, equals negative 2. Now, what we do to one side, we do the inverse to the other. So if we've got x divided by 3, what we then need to do is multiply, because that's the inverse. So x equals minus 2 multiplied by 3. Minus 2 multiplied by 3. X equals negative 6. Because negative 2 times negative 2 times negative 2 is negative 6. We're not adding or subtracting, we're multiplying. Okay, next example. Minus, sorry guys, put my pen back on. Minus 4m equals minus 8. So, inverse operations. First thing we do is we look at this here. Negative 4m. That's the same thing as saying negative 4 multiplied by m. So the first thing we do is we take this away. Sorry, we divide it. So m equals negative 8 on negative 4. Simple as that. You'll notice here we have two negative signs. We can just minus those out. So m equals negative 8 on negative 4 is the same thing as saying m equals 8 on 4. 8 divided by 4, m equals 2. Pretty straightforward. Okay guys, now we're going to look at equations that are a little bit more tricky. They're called two-step equations. So, I'm just going to draw a line down my page here. Let's look at the first example. 2x plus 1 equals 5. First thing we do, here's our pronumeral, here's our culprit. We need to get the things that are furthest away from him. So, the multiplied by 2, that's the thing closest to him. We reverse our order of operations and we start with the 1. So we go 2x equals 5. We do the inverse, minus 1. 2x equals 4. Then, all it's simply a matter of doing is doing the other inverse. So, 2x is the same as saying 2 multiplied by x. What's the opposite of multiplication? Division. X equals 4 divided by 2, therefore 3 dots, x equals 2. Pretty straightforward. Let's do another example. 10 plus 3x equals 13. So 10 plus 3x equals 13. First off, we start with things furthest away from the x. So, trying to find our culprit, we work at the evidence, we work at the crime scene, the basics, then we move on to the more tricky things. So, addition and subtraction are our crime scene. They're the things that are most far away. So, 3x equals 13. 10 is a positive number, so we do the inverse, which is a negative. 13 minus 10. 3x equals 3. Here we go. Then we've got the pronumeral. 3x is the same as saying 3 multiplied by x. Inverse of multiplication is division. X equals 3 divided by 3. Therefore, x equals 1. Really straightforward. Again, like I said to you a few slides previous, guys, if you're ever confused on the answer, just try substituting. So, this is our equation here. It's saying 10 plus 3x equals 13. If x equals 1, 3 times 1 is 3. 10 plus 3, does that equal the answer? Sure does. 10 plus 3 is 13. Okay guys, here's some more examples of solving equations that involve 2 steps. So, next example, 3x divided by 2 equals 3. So 3x divided by 2 equals 3. Now, these two things are on the top. They're in a relationship. We can't touch them yet. We have to touch this one first. So 3x divided by 2, opposite or the inverse of division is multiplication. So instead of dividing by 2, we go 3x equals 3 times, multiplied, keep my words right, by 2. 3x equals 6. Then it's again a matter of inversing. So 3x, inverse of multiplication is division. 6 on 3, 6 divided by 3, therefore x equals 2. Really straightforward, guys. Really simple, not too challenging. Let's try something a little bit more tricky. Let's try 2 plus, that didn't look very nice, did it? 2 plus, or added x on 3 forms a product of 8. So, first thing we do is we mess around with the 2 because that's the thing furthest away. That's the thing furthest away from our pronumeral. So, x divided by 3 equals 8 minus 2. Why 8 minus 2? This 2 here is a positive number. We know that because it doesn't have a negative sign in front of it. Therefore, it's always a positive. If it's a positive, we do the inverse. So, we make it a negative on the opposite side. 8 minus 2 equals, 2 subtracted from 8, 6. Therefore, x divided by 3, let's do the inverse. 6 multiplied by 3, therefore x equals 18. And that's it, guys. That is equation involving one step with negative integers, and 2 steps. Should be pretty straightforward now.